and Assalamualaikum to our lecturer and fellow friend. In this video tutorial, our group will demonstrate how to conduct interpret statistical analysis using IBM SPSS based on our research project, which is the relationship of food consumption experience, destination attractiveness, and food destination image. Before we start, I will introduce our group member. My name is Nurul Umairah and I will be presenting the frequency analysis and reliability test. After that, my friend Aina Shafiah will explain about t-test and ANOVA. And for final part, which is correlation and regression, will be explained by Nurul Adiba. So let's begin. So this is the conceptual model framework and a set of questionnaire. Based on the conceptual framework, the independent variables are taste and quality value, health value, emotional value, prestige value, epistemic value, and destination attractiveness. Meanwhile, the dependent variable is food destination image. After identifying the variable, we need to review our questionnaire. So this is our questionnaire. First, we need to compute all variables. To do this, first click transform and select compute variable. In the target variable box, enter a simplified name for the variable. Then, in the numeric expression box, enter all the relevant continuous variables. Open a bracket, insert the continuous variable, add them together and divide the total by the number of items to obtain the mean score. Repeat this process for all variables until every construct has been computed. Once complete, the newly computed variable will appear in a new section of the dataset. Next, we will do running descriptive analysis. First, go to Analysis, select Descriptive Statistic, and then click Frequency. Move to the variable you wish to analyze into the variable box. Click the Statistic button and under Central Tendency, select Mean, Median, and Mode. Under Dispersion, select Standard Deviation, Minimum, Maximum, and Standard Error of the mean. Under Distribution, select Skewness and Kurtosis, then click Continue. Next, click Chart, select histogram and tick Show Normal Curve on histogram before clicking OK. And then the result will be displayed. So next is a categorical variable, which is gender. Let's look at the demographic data for gender. Just like before, we have a total of 235 respondents who participate with 0 missing data. If we look at the breakdown between male and female response, first we have 63 male respondents, which make up 24.8% of the total. Second, the majority of our respondents are female, with a total of 172 people coming in at 73.2%. So in short, our survey is heavily dominated by female respondents, making up nearly 3/4 of the entire dataset. Next, we will move to a normality test using all continuous variables. To perform this test, go to Analyze, select Descriptive Statistic, and then click Descriptive. The dialog box will appear as shown. Move all continuous variables into the variable box and click Option. Then select all required statistics before clicking Continue and OK. So the result of the descriptive statistic table are shown. The response are measured using a 5-point scale with a minimum score of 1.00 and a maximum score of 5.00. Next, we will conduct a normality test using all continuous variables. To perform the test, first click on Analyze at the top menu. Next, go down to Descriptive Statistic and then click on Descriptive. The the dialog box will appear as shown, and select all your total variable from tqtotal until fdi total and move them into the variables box on the right. Now let's examine the descriptive statistics table. Looking at the means, two variables actually stand out with the highest score. First is EP total with a mean of 4.02 and standard deviation of 0.79. Close behind is TQ total, which score a mean of 3.89 and a standard deviation of 0.86. As for the other variable, they are maintained a pretty solid and consistent average. EV total is at 3.81, prod total is at 3.71, FDI total score 3.65, and HV total come in at 3.656. If you check the skewness for every single variable here, they are all negative, range from negative 0.56 to negative 1.49. This is great news because it proves our distribution is negatively skewed, meaning the vast majority of our respondents gave highly positive feedback throughout the entire survey. Next, how to run a normality and descriptive test on our data. First, click on Analyze at the top menu. Second, go down to Descriptive Statistics and select Explore. Once the window pops up, move your main variable TQ total into the dependent list and move Argentina respondent into the factor list. Next, click on the plot button on the right side. Make sure to check the box for histogram, and most importantly, tick normality plots with test. Click continue and then click OK to generate the result, and the result will show now. Looking at our result descriptive table, it automatically calculates the core statistic for our dataset of 235 respondents. Our mean score is quite high at 3.99, and the median sits at a perfect 4.00. The skewness is negative 1.49 and the kurtosis is 2.86. These values are very important because they give us an initial indication of our data distribution. Next, we look at the test of normality box, which displays both the Kolmogorov, Smirnov, and Shapiro-Wilk test. For both tests, our significance value is 0.00. Since the p-value is less than 0.05, it statistically indicates that our data is not perfectly normal distributed. However, this is very common with large survey dataset where responses are heavily skewed toward positive feedback. Now I will pass the other part to my friend, which is Ainas Shafia, and she will explain about t-test and ANOVA.
Bismillahirrahmanirrahim. So now we want to do t-test and ANOVA. We use parametric techniques, assumptions, homogeneity of variance for ANOVA and t-test. Parametric techniques in these sections make the assumption that samples are obtained from populations of equal variance. This means that the variability of scores for each of the group is similar. To test this, SSPS performs Leibniz test of equality of variances as part of the t-test and ANOVA. The results are presented in the output of each of these techniques. And then, if we obtain a significance value of less than 0.05, this suggests that variances of the two groups are not equal, and we have to therefore violate the assumptions of homogeneity of variance. For t-test, we are provided with two sets of results. So, t-test is SSPS to compare the means of two groups and see if they are significantly different from each other. So, the steps are: we click Analyze, we choose Compare Means, and click the Independent Sample t-test. for a test variable, we choose one from independent variable. So we choose test quality, and for grouping variable, we choose gender. And for group 1, 1 for male, and group 2, 2 for female. We click continue and OK. So this is the result. Here we can see the statistic for male 63 and female 172, and mean 3.8095 for male, and for female 3.8198. For the independent sample test, we can see the significance is 0.042 less than 0.05. So it is variances, and we can only reverse equal variances as soon. And see the significance for two-tail 0.944. So the guidelines for interpreting this value are 0.01 for small effect, 0.06 for moderate effect, and 0.14 for large effect. So the significance is 0.042. It is moderate effect. Next, we want to do ANOVA. ANOVA, analysis of variance, is a statistical test used to determine whether there are significant differences between the means of 3 or more groups. ANOVA compares the variation within groups and between groups to see if the group means are different from each other. First, we have to compute the find, which is compute the variable. After we compute the variable, we want to do ANOVA. First, we click Analyze. We click Compare Means and choose one-way ANOVA. On dependent list, we put the variable that we compute, TQ total, HV total, and EV total. And I choose number of visit as a factor. As we can see on the questionnaire, it has 5 selections on the number of visits. So we want to see the variable more than 3 groups related with what we want to test. The option descriptive, homogeneity of variance test, Brown-Forsythe, and Welch. Also click mean plot and exclude cases analysis by analysis and continue. And we click Turkey and continue. And we click OK. So we just focus on ANOVA. The results show that TQ total had a significant ANOVA result with significant less than 0.001. This indicates that respondents from different visit frequency group persist. Similarly, for HV total also show a significant result with value of 0.023, which is below the significant level of 0.05. This means that respondents enjoy and emotional experience differ significantly according to their numbers of visits. However, EV total produce p-value of 0.269, which is greater than 0.05. This suggests that there is not statistically significant difference in exponential value among the different visit groups.
Welcome to this step-by-step tutorial on statistical analysis in SPSS. We will begin by looking at our dataset in the Data View tab to ensure everything is formatted correctly. First, we are going to run a bivariate correlation to see how our variables relate to one another. To do this, navigate to the top menu bar and click on the Analyze menu. From the drop-down list, look for Correlate and click on Bivariate. A new dialog box will pop up showing all the variables from your dataset on the left side. Carefully select the variables you want to analyze and click the center arrow to move them to the Variables box. Under Correlation Coefficients, make sure Pearson is checked. We will also use a two-tailed text. Ensure that Flag Significant Correlations is selected so SPSS highlights important findings for you. Review your selections. Once everything looks good, go ahead and click the OK button. The SPSS output window will appear, displaying your newly generated correlation matrix.
Now that we have analyzed the correlation, let's move on to running a linear regression. Go back up to the main menu at the top of the screen and click on Analyze once again. Scroll down the list, hover your mouse over Regression, and then select Linear. A new window will open where we need to assign our dependent and independent variables. Find your main outcome metric, select it, and click the arrow to place it into the dependent box. Next, select your predictor variable or variables and move them into the independent box below it. On the right side of the window, click on the Statistics button to adjust our output options. Make sure both estimates and model fit are checked to get a complete summary, then click Continue. Double-check that your variables are in the correct boxes and click OK to run the regression. The output viewer will generate your model summary, ANOVA table, and coefficients table. And that's it. You have successfully completed both correlation and regression analyzed in SPSS.